Hello friends, this is part 2 of Mathematical Physics Paper Solution 2019 set by Dibrugarh University for BSc First SEM Physics Honors. So link of the part 1 is given in the description box. So in part 1 we have solved from question number 1 to question number 4b2. So in this video we are going to continue from 4b2, right? So in the first one we have solved from question number 1 to question number 4b1, right? So if you're new to my channel, please subscribe the channel and if you like, then hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Okay, so this is for BSc first sem physics honors, right? So now let us start. This is question number 4b2. This is question number 4b2, right? So now let us solve this. Now if you see this question, let me write the given equation first. So this is the given differential equation. We need to solve this. So you can compare with n dy plus m dx is equal to 0. If you compare with that, you will get n is equal to this, and del n by del x, if you differentiate partially with respect to x, then you will get twice x 1 by x. If you apply here the product rule, then twice x 1 by x plus log of x, and if you differentiate twice x, you will get 2 here. So that is what you will get. And if you differentiate partially this, then you will get y only, because derivative of x with respect to x is 1. So similarly here you see it x cancel, so you can take 2 common, this one and this. So now you can take this 2 common. So on taking 2 common, you will get 1 plus log of x minus y. That is what you will get. So similarly you can find you will get m is equal to twice y, and if you differentiate it with respect to y partially, then you will get 2 here. Now here you can see that here del n by del x is not equal to del m by del y. So here in this case what we can do here, so del m by del y is not equal to del n by del x. So here del m by del y minus del n by del x, or you may take del n by del x minus del m by del y. You can do what, let me tell you. Here you see, you can express this del m by del y minus del n by del x. If you divide this n by n, and you may express this as a function of x only, or you may take either del n by del x minus del m by del y divided by n. You may express this one as a function of y only. So which one is possible, do that one, right? So now let me clean this first. So here you see, now this is what we have got. Okay, so what we have done here, we have subtracted del n by del x from del m by del 1, and doing so we have got this result. So now you say, if you open the brackets, then you will get this. Here 2 cancels, so we have got minus 2 log x plus y, right? Minus 2 log x plus y. That's what we have got. Now you see del m by del y minus del n by del x divided by n, and then what you will get. So this is your del m by del y minus del n by del x minus 2 log x plus y, and divided by n. What was n? This is n. Here you see. So divide it by the value of n. If you put here, then what you will get. So from here you can see, you can from the denominator you can take x common, right? So then you will get this, right? So here these 2 cancels. Now what you will get, So this is, you can see, minus 1 by x. This is a function of x only, right? So now let us find the integrating factor, e to the power integration of f of x dx, and that's gonna be equal to e to the power integration. Here f of x we have got minus 1 by x and dx, and integration of 1 by x is log x, so here minus 1 by x, so we will get minus log x, right? E to the power minus log x, which can be written as log x to the power minus m1, right? And remember that this is e to the power log of m is equal to m. Remember this one, we have used this rule to find the integrating factor. Here you can see e to the power log of x to the power minus 1, that's going to be x to the power minus 1, that's why we have got 1 by x, right? So this is integrating factor. Now what we're going to do, we're going to multiply the given equation, given differential equation, this one. So let me suppose it as equation number 1, multiply equation number 1 by the integrating factor, and if you do so, then you will get this, right? So after multiplication of integrating factor with the equation number 1, we have got this. Now what we're going to do, here you see, we're going to integrate m dx. First compare this equation, whatever you have got after multiplication of integrating factor with the given equation, compare this one with this equation. Then if you compare with this, then you will get this part is m, this part is m dx, and this part is your n dx, right? N dy, sorry, n dy. So now let me go to the next slide. So this is the given equation we have compared with m dx plus n dy. So now what we can do, we're going to integrate m keeping y constant, right? Dx plus, then integrate the terms in n which do not. So now integrate the terms in n not containing x, dy is equal to c, right? So this equation will give you the solution, right? So here you see and what we have got, integration dy by x dx plus integration minus y dy is equal to c. And if you here you see this y is constant here, so here this y is constant, and integration of 1 by x, we know log of x, so then integration of y will be y square by 2, then is equal to c. So this is your solution. So hope you have understood. This is our next question. Describe the method of Lagrange undetermined multipliers for a constant system. Suppose here you see, suppose we have a function of 3 variables x, y and z, function of 3 variables x, y and z, and subject to constraints phi x, y, z is equal to d, where d is a constant. Now you see, this function of x, y and z to have stationary value, there must be a constant lambda, suppose, such that grade f must be equal to lambda into grade phi, right? So that implies del f by del x plus del f by del y del f by del z is equal to lambda into del phi by del x, lambda into del phi by del y, lambda into del phi by del z, right? And from this, if you compare all the 3 components, then you will get these 3 equations. So let me write here, right? You will get these 3 equations. Now this is suppose equation number 1. Let me take this as equation number 1, right? This is 2, 3 and 4. if you solve these 4 equations, then you will get the values of x, y, z and lambda as well. Okay, so you will get x, y, z and lambda, right? So this is all about Lagrange undetermined multipliers for constant system. Here this constant lambda is called Lagrange multiplier. Okay, so this constant is Lagrange multiplier, right? So let me mention somewhere. So lambda is called Lagrange multiplier, right? So hope you have understood this. Now let's move on to next question. So this is question number 5. Here it is asked that a cross b is 0. Is it necessary that these two vectors are parallel? Must be parallel. So now you see, if a and b, if they are not equal to 0, then it is necessary to be equal. Otherwise, not. If any one of these two vector, either a or b, if their magnitude, any one of the magnitude of vector a or vector b, any one, this one or this one equal to 0, then it is not necessary that a and b must be parallel, right? So simply our answer is just you can write no. If let me show you here, just clean this part. This is a dot b sine theta, right? A cross b. If any one of this a and b is 0, then a cross b will be equal to 0 even if theta is not equal to 0 degree. That means a and b are not parallel, right? So that is your answer. So let's move on to next question. This is the next question, question number 5b. So here we need to prove this. So vector scalar triple product. So these 3 are equal. We need to solve it. So how to solve this? So then let me show you. So proof. So suppose let us consider vector A is equal to this, and this is vector B. This is vector B, right? And this is vector C. These are the 3 vectors, right? So how to find a dot b cross c? So using determinant we can find a1, a2, a3, b1, b2, b3 and c1, c2, c3. If you find b dot c cross a, then you will get b1, b2, b3, c1, c2, c3, a1, a2, a3. Then if you find c dot a cross b, then you will get c1, c2, c3, a1, a2, a3 and b1, b2, b3. So now what you're gonna do, just you see, interchange these 2 rows, second and third row, right? So let me divide them. So if you interchange these 2 rows, first and second rows, then you will get this, and here you will get a minus sign here. Okay, so what we have done, row 2 and 3 are exchanged. Now what you gonna do, we are going to do we're gonna exchange again that first and second row. So these 2, first and second row. Now if you interchange them, then what you will do again, you are going to get another minus, which make this minus will positive. So this minus will be positive now. So then interchanging 2 and first and second row, you will get this, right? Interchanging first and second row. This is nothing but this b dot c cross a, which is now it becomes equal to a dot b cross c. Similarly, in the next part here you see, we can interchange first and second row, and doing so we will get this determinant and a minus here, right? Minus here. So again we are going to interchange these two rows, second and third row. Let us then this minus will be positive again. So interchanging that first, so we have got this by interchanging the second and third row, right? So let us interchange here. So what we have done, R2 and R3, these are interchanged, right? So that's why we have got now, so just let me do a little bit of adjustment here. So here we have done that we have interchanged R2 and R3, row 2 and 3, right? So and doing so, what we have got, A dot B cross C, right? So if you compare these three results, then you will get these three, all these three are equal. So that's how we can prove. So now you see we have got A dot B cross C is equal to this, which is equal to again B dot C cross A. If you see the result, if you see this result, and we have got again B dot C cross A is equal to A dot B cross C. Similarly, from this C dot A cross B, again we have got A dot B cross C, which is equal to B dot C cross A again here. So from here it is proved that all these three are equal. So now let's move on to next question. So this is our next question. We need to find the sine angle between these two vectors A and B. These are the vectors given here. So let me show you how to solve this. So let us write the given vectors first. So these are the two vectors, and let me find their magnitude as well. So this is the magnitude of A, that's going to be equal to root over 2 into 25, because you see 9 plus 16, 25, 25 plus 25, you can write 2 into 25, and the square root of 25 is 5. So that's why 5 root 2 you will get, and this is vector B, and if you find its magnitude you will get root 2, right? So we have got the magnitudes, and now here you see suppose theta beta angle between these two vectors A and B, so A cross B will be given by A B sine theta, right? Now A cross B can be found out using determinants this way, I cap, j cap, k cap, and then components of vector A and components of vector B in the next row. So if you evaluate this determinant, you will get I dot, then minus 3 minus 1, that's going to be plus 3, minus 1 into 4, then minus j cap, again 5 into minus 1, that's going to be minus 5, minus 0 into anything is 0, so that's why here 0 we have got k cap, then again 5 into 1 5, minus 3 into 0, again 0, right? So again A cross B, we have already got that AB sine theta, so if you put here AB sine theta, now evaluate this from this vector, this result, what we have got, minus I cap plus 5 j cap. From this one we have got minus I cap plus 5 j cap plus 5 k cap, and put A and B, values of A and B you have calculated here, so put those here. Right, so sine theta will be equal to, so 5 root 2 into root 2, that's going to be 10, so minus I cap plus j cap, 5 j cap plus 5 k cap divided by 10. So this is your answer. That's how we can solve. So now let's move on to next question. So this is question number 6. Evaluate this surface integral r dot n cap ds, where S is the surface enclosing a volume V, and R denotes the position vector of a point. So now how to solve this? So here we're gonna use the divergence theorem. So here we're gonna use the divergence theorem solution. By divergence theorem, by divergence theorem, what we're gonna have? So surface integral r vector dot n cap ds, right, ds will be equal to volume integral divergence of vector r dv is equal to, so this is the del operator. We know the del operator, that is what, del by del x I cap plus del by del y j cap, right, then del by del z k cap, that operates on the position vector. Position vector is given by simply this r vector will be considered as x I cap plus y j cap plus z k cap. Remember that. So here you will get x I cap plus y j cap plus z k cap dv, right? So that is what given by the divergence theorem. Now you see what we're gonna have here. So if you multiply these two, this one and this one, that means if you take the dot product of these two, del operator and the position vector r, then what you're gonna have here, volume integral dx by dx, del x by del x plus del y by del y plus del z by del z. You're gonna get this dv, right? So this is gonna be equal to 1, this is gonna be also equal to 1, this is gonna be also equal to 1, right? So what we're gonna have, volume integral 1 plus 1 plus 1 dv, that's gonna be 3, right? So 3 can be written out of integral. So volume integral dv, if you find a volume integral dv, you will get the entire volume v, so 3 into v. So that is your result. That's how we can evaluate. So hope you have understood. So remaining questions will be solved in the next video, otherwise this video will be very long and boring also. So that's why from the next in the next video we are going to start from 6b, right? So here we have solved from question number 4b2 to 6a, right? So hope you have enjoyed the video, and if you have enjoyed the video, then share with your friends and hit the thumbs up button, and if you are new to my channel, subscribe the channel. So stay connected. Soon I am gonna upload the next part. Okay, so thank you for watching. See you in the next video.